So lecture number 7 is on the concept of decision support and artificial intelligence. We have this one, and then we have software architecture, software as architecture, software as a service. We have a couple of other topics after this that I'll finish up next week if I don't finish them today, because we are winding down on our list of topics. But artificial intelligence is an important one, especially when it concerns business these days, and then engineering management deals with intelligent forms of business practices. So decision support as it applies towards artificial intelligence, comparing and contrasting the decision support systems and geographic information systems, as well as expert systems, and looking at neural networks and fuzzy logic and all these AI tools that are out there. So what I'm going to do is going to hit you with a bunch of buzzwords. And the buzzwords are going to be things that relate to business aspect. I can actually tell you about fuzzy logic and neural networks without getting too technical, actually, because they're all business concepts and their way of getting business intelligence. Because today's business economy is all about intelligence, data mining, data warehouses, business applications that are highly intelligent. And so also geographic information is used these days. We can't actually get past it with Google and all of the location services and things that are associated with the services of software programs and utilities that are all based on where we're located. So that's also a form of business intelligence or artificial intelligence as well. Falls into the same categories. We'll look at the genetic algorithms actually and how they're composed without looking at the technology. Also agent-based technologies. The internet is all about agent-based technologies these days as well. So GIS, graphical information systems, are based upon, as you might guess, graphical, map, geographical information, maps. In fact, that's one of the biggest areas right now, well, has been for like maybe about 10 years so far, in terms of internet and app development and services. Looking at and allowing you to see information spatially on a map or a form of a map, and also being able to locate, as an example, in rural areas and in other spots. There's way too much talking going on in here. I feel like I'm... Thank you. Okay, good. All I have to do is stop talking and then everybody else stops talking. All right, so looking at in terms of, and this is just a particular case study that comes out of the book that this lecture was based on, in terms of research and scientists looking at geographical information systems to locate debris from the shuttle Columbia as an example. If we use a map, we can find bits and pieces of a space shuttle or a plane or something that's located in a desert or remote area without having to comb the area. Well, we can also use it for location-oriented services, so we can find out, as an example, which merchants are in our area, which services, more so for market commercialization, commercial market applications and stuff. Actually, there's a couple of GIS applications that are pretty good right now for finding parking spaces in heavily populated cities. With the sensors, there's also a couple of privatized apps out there that basically find rental spaces, rental parking spaces. You can actually, in San Francisco right now, you can rent parking spaces by an hourly basis. And you download an app, you look at it, and it shows you on a map, and it actually will direct you to the space. And then when you get there, you press a button, and then when you come back, you press a button, and it charges you for as long as you've been there. And it's somebody's private space. So imagine the concept of being able to use the space out in front of your house or something. But in the city, it's actually marked, and it's zoned for permits and stuff. So it's not like you can just do that with any city space. You have to do it with something that you have access to, or that it belongs to you. But that's an example of using a geographical information system to make an application to basically as a business concept. Also, the city of Richmond, Virginia uses it to optimize the 2,500 bus stop locations. Actually, most of the public transportation these days have apps and utilities, so you can tell, I don't know if County Transit has this yet, but I think they do actually. You can tell live what time the bus is going to show up, so you can look at the app instead of looking at the sign. Because sometimes those signs, have been up there for years, you don't know what time they're going to show up. But the technology will tell you when the bus is on its way, when it's late, stuff like that. So can certain peer-to-peer apps when you're on the freeway can tell you if there's any accidents or anything in your near future. Actually, it's kind of interesting. I can't remember the name of the app, but there's one in particular that a couple of my friends are using, actually. When you're stuck in traffic, you can communicate with the car in front of you and the car behind you through this app. Yeah, what is it called? I can't remember the name of it right now, but you're like you subscribe to it, so you are allowed, and then they can ping you and they can say, hey, can you see it's clearing up there? There's a couple of them out now.
One is Phase, there's another one called Escort.
Escort?
Yeah, Escort.
Yeah. Where you're just stuck in traffic and you're like around your local vicinity, you can talk to your neighbors and their cars and stuff. Yeah, what's it called? Yes, that's the one I'm thinking of. But it's nice when you're stuck in traffic. The only problem is every time I've used it, nobody's on there. It's been empty. Or there's like one person and they're not responding. Because, well, it's kind of counterintuitive when you're not supposed to be using your phone in your car. So now there's an app that you're supposed to use when you're in your car driving. It's like, I don't know about that. Anyway, for various reasons, geographical information can be used to create applications in a lot of different categories for a lot of different utilities. So one form is visualizing the information, and the other form is for making decisions. In some of the Waze apps, as an example, there can be made for a decision in terms of how long do I want to wait in this traffic? Should I just get off? Should I take another exit? Or is this traffic going to clear up? Things of that nature. If you're a business and you're trying to use geographical information, you might be considering, what are the busiest time of day for customers? Where should we locate ourselves? All sorts of different things based on that. So you can use web-based map services to get directions, find locations for buildings. And you could use real estate agents to take advantage of this for GIS, actually. In fact, realtors in general, who are very familiar with the location can strategically give you information like, for example, how far away you are from a school or how far away you are from grocery centers and stuff like that. Benefits of bank, waiting to determine optimal placements for ATMs and stuff like that as well. So the reason why we're looking at this is because it makes great material to come up with different applications and different development efforts to improve the decision making in a company. So as an engineering manager, you're often making decisions, and the decisions that you're making are reliant upon the assets and resources that you have available to you. So if you take advantage of artificial intelligence and data in general and use mining techniques or discovery techniques, you can actually use that to apply for better decision making, which is the basic theme of today's lecture. So in terms of the phases of decision making, we have intelligence, design, choice, and implementation. So from an intelligence perspective, we're going to find and recognize the problem or the need or the opportunity. So most of the time, what you're looking for is opportunity or you're looking for need. It may also be solving a problem in terms of, well, how do we increase our sales? Or how do we get our word out about our product or something? In terms of the design, we're considering the possible ways of solving the problem. Once you've identified what the problem is or where the start is on the decision making. And then the choice is basically weighing your options, and the implementation is carrying it out and making a decision off of that. So here's our 4 phases of decision making. So just like we can take and apply a software development lifecycle model to a development plan and actually create phases and steps to proceed through a development project, we can apply the same kind of model for decision making and use a structured approach to applying this towards making an appropriate decision, hopefully. So in terms of the intelligence part, and we look at these 4 phases of decision making as intelligence, design, choice, and implementation. From an intelligence perspective, we need to find what to fix. So that's where the management theory comes into place in terms of solving what is the problem versus what's a symptom to the problem. And the management people come up with about 15,000 different ways of estimating or predicting what a problem is, which is actually kind of interesting. All the way from a fishbone diagram to a balanced scorecard to any number of different strategical kind of ways of discovering problems. In an engineering perspective and from an engineering manager's position, you may not necessarily be trained as much in that business theory, nor would that business theory sort of apply towards your industry or towards your technology, because you're essentially working in an environment that's hopefully new. upcoming, cutting edge, perhaps, hopefully, and something in which there may not necessarily be some found research for. As an example, if you're working in a retail store, it's very easy to figure out certain things about the traffic flow, or certain things about the customer service, or certain things about the nature of the business, because the business is around everywhere. There's tons of different retail firms around there. You're making a chip or a new product or providing a new service or something, there's probably, hopefully, not 1,000 people doing your same industry. So identifying and figuring out what you need to fix is usually a big stopping point in most of the decision making, because people spend a lot of time trying to figure out what's wrong with the situation. Where the business intelligence would play a part in this, and the business intelligence would hopefully be able to provide you with the information that's missing from this particular stage. And then the first question people ask is, well, where do I get this intelligence from? Well, that's going back up to the concept of artificial intelligence and information gathering. Those are the techniques I'm talking about today in terms of applying the business intelligence or creating the intelligence. So if we could possibly imagine that we've got the intelligence, we've got the problem identified, now designing or finding the fixes to the problems would be the next step. And then the choices, hopefully there's more than one choice to fixing the situation. And then at the end, this is a no-brainer, that's the implementation, apply the fix to the problem. And then hopefully the problem's gone away, or situation hasn't changed into a new problem. And then we start all over again, back to the beginning, and we define a new problem. So here's the types of decisions you face in terms of the kind of the area of science that's associated with fixing the problems, in terms of what you're going to be running into: structured design, non-structured decisions, structured decisions, recurring decisions, or maybe non-recurring ad hoc decisions. I'd say it depends on the industry and it depends on your management position. Most likely you're not going to hit too many structured decisions. If you do, you're doing a lot of tactical work, you're not doing strategic level management, and if that is the case, you're probably working too low in the totem pole. So a structured decision, and these are different types of decisions that would fall into the categories of the problems to be solved, decisions to make. You're processing a certain information in specific ways that you will be always able to come up with the right answer. If it's structured, you're always going to come up with the same answer. As an example, the company is running low on funds. Well, we need to make more money. Yeah. Well, or we need to save expenses or something. It's not too bad. It's just structured category. The non-structured category, there might be several right answers. And without knowing which one is the real right answer, it's unstructured. So in that particular case, you can take and use some heuristics with some previous decisions that were made at the same company, or maybe some artificial intelligence or some technique to turn the non-structured into a more structured or a more predictable type of environment. You also have reoccurring decisions. You don't usually end up with too many of those happening, decisions that in terms of having to do it repeatedly. Well, that you usually get with the service industries, and you get with companies that have been around for a while, because it's common decisions you have to make in terms of when to fire someone, when to hire someone, when to stock the inventory, when not to stock the inventory, when to have sales, when not to have sales. Those are reoccurring, and they're usually planned in. And then non-reoccurring or ad hoc decisions, when you make them frequently, when to relocate the company, or when to bring on a new product line, or something like that. So usually what you'll end up with for the most complex type of decisions are the non-structured decisions that happen sporadically. So here's the kind of the difficulty level, where we have the reoccurring is probably the easiest decision to solve. And then the structured is probably going to be the next easiest. But this category here is the unstructured, the most difficult decision, and it's non-reoccurring. Most engineering managers fall into this most difficult category. So this is where I say you need to be a little bit more creative in terms of your decision skills. So the purpose is essentially to arm yourself with skills that won't apply to anything, because every decision will be brand new. Every decision will not have a form of a basis in any previous decision you've ever made, nor will you be able to consult with research or anything to come up with an answer to this problem that you're going to have. and your skill in being able to solve the unstructured decisions that you need to make is what's going to make or break your career usually, because you'll either get promoted because they'll figure out, oh, you're a good decision maker, or you'll get demoted or fired, or you'll move on to another company because you make bad decisions. So we'll see what happens. All right, so decision support systems. This is one approach to solving this problem. Generally, what you're looking at is support for the unstructured to make the structured into a more structured, to avoid the unstructured, because you want to try and do is avoid the unstructured decisions. So how do you avoid an unstructured decision? Well, you add some structure to it. You make it into something that's understandable. So a decision support system can do that for you. How can I do that for you? Well, it's a highly flexible, interactive system designed to support decision making when the problem is not structured, which means you have to add some components to it. So a nice little example of that, in fact, a nice little example of the unstructured, non-reoccurring decisions that you have to make is something in terms of the stock market. People have been spending years coming up with stock market analysis programs. They're using decision support systems. They say buy, sell, relocate, do something. Basically, the analysis gets done on a bunch of data, and the data is going to be the fluctuations in the stock prices or in the frequency of people buying and selling, or market or economy conditions or something of that nature. All the information is gathered, it's analyzed, and then the program says buy, the program says sell. And then people rely upon those systems. Actually, they don't. They rely upon multiple of those systems, because usually one system is not a good judging point. So you have 5 different decision support systems, and then you compare them and you go with the average. Or you do what a couple of my friends do, actually. They've been really lucky with the stock market, actually. Is that they look at all them and then they go against that. Because if you're looking at this and everybody else is looking at this, and they're very popular programs, and you look at how many people are using this program, if they all vote a certain way, you go the opposite direction. Because it causes an unnatural shift in the market. So, which essentially is another strategy. But long story short, what I'm describing to you is the nature of this unstructured decision making. So you're not going to get a perfect situation in which you have all of the information and you have all of the data and you already know the right decision. If you did that, there would be no need to hire you. They can just have a computer do your job. So instead, it's your skill in being able to make unstructured decisions that makes you a better manager than another manager, essentially. And a manager that can't make a decision at all should not be in that position, really. Decision support systems help you analyze, but you must know how to solve the problem and how to use the results of the analysis, which is the other key point. So whether or not you buy and sell according to what the program says, or you work against it. Actually, I have found that to be quite reliable. You know, back when with the Apple stock, my only claim to fame is how lucky I was with my Apple stock, because everyone was saying, oh, the stock's going to go down, after we had, people pass away, people move on, new products get put out, things happen in the economy, everything changes, and then you listen to the media. The media says, oh, the stock's going to go down, everyone starts selling, right? Well, I bought Apple stock at that time, and I bought a lot of it, actually. And then it practically doubled from today. I haven't sold it yet. That's my retirement. Holding on to it. But I just went against everybody else. I just totally just said, oh, you know what? People are, follow the bandwagon. Happens the same thing with the economy. As an example, some of the best jobs you can get when people think there are no jobs because the economy sucks, when there's like thousands of jobs up, but no one's applying for it, they've all given up, or they're all settling for less, or they're not doing, it's like working against the masses, essentially. But that's an unstructured, that's an approach, using a decision support system that's inherent in terms of the unstructured nature. So as a manager, that's what you're going to do. Instead of, you can't buy a textbook and you can't read about this stuff. What ends up happening is you have to come up with your own philosophy in terms of how you're going to handle that when those decisions get hit. So alliance between you and a decision support system, what you bring, experience, intuition, judgment, knowledge. The advantages of using the system is hopefully some sort of increased productivity. So maybe some better understanding. So, or some increased speed or flexibility, maybe some reduced costs. What the IT brings, what the technology brings, is the speed, the information, and the processing capabilities. So the components of a decision support system, and some of you will probably actually be putting together the decision support systems for the company. Maybe some model management components, some data management components, and some user interface components. So in terms of a model management, looking at the models from a management perspective, management models. From a data, it's a database or storage capabilities, maintaining the information. And from a UI, well, it's how you're going to communicate with it. It's not like, actually, the components these days, it's not like deciding on a UI. It's deciding on the user experience. It's deciding on, well, is this going to be a mobile thing? Is it going to be an internet thing? Is it going to be running on my microwave oven? Kind of thing. Which is, actually, I say that kind of jokingly, but it's true. Do we want the appliance? We have appliances now that are very smart. An example, TVs, microwave ovens, refrigerators are extremely intelligent these days as well. Security systems are even more intelligent. So what a lot of successful manufacturing people are doing these days is thinking out of the box, thinking out of the mobile. Actually, mobile is really old right now, actually. It's no longer mobile. Now it's, is it going to be on my microwave oven? Is it going to be on my refrigerator or my smart TV? Which is kind of interesting, because your smart TV now these days can actually serve as a host, can actually serve as a networking component, and it should be part of your network. Well, and so should your service, your cable service, your telephone service, your wireless service, and products that are bringing all that stuff together, which is like a lot of the Sony stuff right now, actually. Mixing multimedia, mixing entertainment with utility, those will be the people that make the money, essentially, off of those products. So anyway, as an engineering manager, I usually call that entrepreneurship. It's not really. It's actually just thinking out of the box. It's thinking, what does my refrigerator need that my refrigerator doesn't have right now? Or my toaster oven, or microwave, or something like that. Because it's no longer a matter of it being computerized. It's what features will it offer. It's a better choice. So components of the DSS system here we have, and this is kind of a big picture of everything looks together. We got number one, Bob says something, and then we have questions, and we have answers, and then we have, now Bob says this after he said that. We have all the information coming in, and we have the user interface management that's coming into it, along with our choices of models to apply towards this information, and then we get our data management that comes in terms of keeping track of data and using the data to make the better decisions with it. Because if we knew that, then we'd know who our customers are and what products do they want and when are we going to deliver them and what kind of decisions are we trying to make, modeling out what activities they have. So Bob's original question here is, what financing options will cost the least to buy the house when the principal and the interest are all paid? And what options will result in the lowest monthly payments? And then now he says, well, now then figure out the total cost of the loan options and the payments for each loan, given all these other options that he has. This is just a decision to make a loan, actually, so as an example, which is actually a fairly easy decision these days. So in terms of the Geographic Information System, it's the GIS, it's a decision support system that's based on the spatial information. Spatial information of any information associated with any map. So most people, when they think of maps, they go, oh yeah, I have a GPS system in my car. I'm sure everybody has a GPS system in your car. But what about those new systems that they have right now to track people in malls that use Bluetooth? So we can actually track patterns. And there's another guy, actually, I was reading this thing recently, it's called ant theory. Basically tracking how long an individual will stand in one position looking at something and treating basically the population as a bunch of ants and the theories in which the ants following each other. So it's for route manipulation. So you can design, let's say for example, the pattern of your floor, your shop floor, or your retail floor, your establishment, to take advantage of the human nature of ants and how they will group together in certain areas of the floor and how they will migrate and move throughout the location. And how do you get that? By studying Bluetooth connections can find out a lot about a person and how fast they move. There's applications actually out there, utility kits, APIs that work with Bluetooth tools, so you can track customers throughout a shopping mall, throughout a store, walking habits. What path do they take through the mall? What path do they take through a store or establishment? Well, you can also do that with a park. What path do they take through a park or through a city? Which is actually kind of interesting, because the more you understand the human behavior, then the more you can actually know to make better decisions associated with it. Where am I going to put my store? Well, I'm going to put it right there. Why? Because everyone drives over there. No one knows, because you have the information, hopefully, to back up that decision. So businesses use GIS software to analyze information, generate business intelligence, and make decisions, long story short. Zulu GPS software for Denver apparently is looking at GPS locations. Actually, your car can be tracked in reverse from your GPS. So I'm waiting for the I'm waiting for those Google cars to get out there, actually, because that has a ton of transmitted signals all over the place. So as we're walking technology these days, which is actually kind of a cool thing. So let's talk about artificial intelligence. You don't have to take an AI class, but there is an entire AI class here at ITU, believe it or not. If you have an interest in this, it counts for the engineering management degree, actually. In terms of, because there's a lot of artificial intelligence used in engineering management, what you're looking at are a couple different forms. I'm going to go through some of the science and the mechanisms in a very low-tech business way. So from a traditional perspective, artificial intelligence is seen as mimicking human thinking. From an engineering perspective, the modern day view, it's understanding the human and replicating human decision making and human thinking with computer applications and software. So we're no longer trying to build a robot anymore. We're trying to build something that can think and can work properly to mimic what we would do if we were human and we're hardware. So it makes the hardware think like a human, essentially. So expert systems, neural networks, and fuzzy logic, genetic algorithms, intelligent agents, and agent-based technologies. Pretty much the focus area for today's technologies in terms of artificial intelligence. Adding in, of course, it can't replace the GIS capabilities these days either. So expert systems, knowledge-based systems. An artificial intelligence system that applies reasoning capabilities to reach a conclusion. Now, what does it use for diagnostic problems and prescriptive problems? What to do, what to make, what to do, how to think. When I always think of expert systems, I think of triage, and I think of automated systems. As an example, every single car manufacturer uses an expert system. Every single car sales place uses an expert system. Every single bank uses an expert system. In fact, we all live for 3 expert systems. They're called credit reporting companies that give us a score. They say you are this, and I don't know what the scores are these days, but it tells you're a 700, you're a 600. And you say, well, what makes me a 600 and what makes you a 700? Well, there's about 1,000 different little things maybe that go into that. And so that's an expert system. It's a result of an expert system. In the old days, in terms of businesses, it would take, I don't know how long, maybe about a week or something like that to come up with a decision, depending upon how far back you want to go for a car loan. Now it takes less than 5 minutes, actually. Now you can do it yourself online and actually get pre-approved and qualified without even talking to an expert, because you're not talking to an expert anymore. We replaced the expert, no more experts. Now we just have expert systems, which is actually kind of funny because people in some industries rely on the expert system, which is kind of interesting. Now you just press a button and then something gets done. When in the old days, people had to do it by hand, or people had to actually think about something. Now it's, did you fill the form out correctly? Because if you didn't fill the form out correctly, you're not getting a job these days. Because now no one looks at resumes. You just put it through electronically. You don't fill the form out, you don't get the job. You don't put the right buzzwords on the form that you're filling out, no job for you. So it's because no human's looking at it. Instead, it's going through a filtered system. It's going right in. In fact, there's a couple services that process for big companies, process resumes. So not even the company looks at your resume anymore. Some service, some expert system looks at your resume and says, okay, you should get interviewed. You're not getting interviewed. You're getting interviewed. And it's just in terms of playing with the expert system. Well, that's what people do with car loans these days too. That's what they do with house loans, and that's why we were in such a big problem a couple of years back there with the mortgage industry, because there was a lot of bad loans written for people who weren't really qualified, because they tweaked the expert system to make more people qualified. So they do that with education as well, though. They tweak it so that you can get admitted, even though maybe you shouldn't be admitted. But you get admitted, you take the first couple semesters, we collect the tuition from you up ahead of time, and then you end up failing out, and then we get to keep the rest of your tuition, and then you go bye-bye. And we get another group that comes in. So there's schools that work like that. There's schools that work in different strategies, because they know who should be admitted and who shouldn't. So here's a traffic light expert system. So we have a bunch of rules. We have symptoms or facts. So is the light green, is the light red? What's the state of the light? Yes, if the light is green, then go through the intersection. And no, go to rule 2. If the light isn't green, is the light red? Is the light yellow? So then you move to another rule. Explanation, well, should be safe if the light is green. If not, you need more information. So which is a rule-based system, actually, which is kind of easy to follow. In fact, you might think that human reasoning, now if you take a psychology course, you might think that human reasoning is nothing more than an expert system, which this is what it's actually based on human thinking, human reasoning, which is an expert system, actually. So, because we're all experts, right? So, well, in what we're trying to do, hopefully, unless we make mistakes. So what can they do and what they cannot do? An expert system can reduce errors. Yep, sort of like using a calculator. I trust a calculator these days over my math skills, only because I've relied on a calculator too long and I don't do very much math by hand anymore, and nobody does really. Just like spell checking, actually, when I use a computer and I type in Microsoft Word, I have certain words that I constantly misspell, but I don't correct it because I know that the word checker will correct it. And actually I do that with email too. I like to put extra I's in words and they will always take it out for me. I go, okay, great. But maybe I should, but my expert system isn't adapting to this. It's not being trained well. Instead I'm using another expert system, the spell checker, which is another example of an expert system. We can use it to improve customer service. Yep, we can use it to reduce costs. It doesn't replace people, it just makes people more intelligent. Just like a calculator doesn't replace the fact that a human should probably take a math class, but it will help the human with the math class do a much better job in the class, depending upon the level of math. It can't use common sense and it can't automate all processes. No, it doesn't use very much common sense. In fact, that's why a lot of these people go, well, can I have a car drive itself like an expert system? Actually, it's working. It's using common sense. No, it's using rules. And sensors, so lots of sensors. Which brings us to fuzzy logic. So from an artificial intelligence point of view, there's a ton of expert systems in business. There's a ton used in management levels. And some of them are ad hoc and some of them are actually formalized expert systems. Fuzzy logic is practically used everywhere these days. When you step on your gas pedal in your car, you're using fuzzy logic. You're getting a little bit of pressure, a little bit more pressure, a lot of pressure. You're getting groups. If you had to dial your gas, 1, 2, 3, 4, 5, it'd be very inefficient. Not only would you not be able to speed up or slow down properly, but you don't know the accuracy of exactly what number to put it on. But when you apply pressure, then it's a feeling, it's a sense, which is fuzzy logic. So they originally came out with fuzzy logic for temperature and other types of controllers. So a lot of controllers use fuzzy logic. As an example, air conditioners and heaters, monitors, controllers. What does that mean? Actually, even your microwave oven uses fuzzy logic. What does that mean? Well, if in the original days when we had logic that wasn't based on fuzzy numbers, it was based on pure exact numbers. If we say we wanted the room to be 70 degrees, when it was 69 degrees, the heater would come on. And then at 71 degrees, the air conditioning would come on to bring it back down to 70. We can't keep it. There's no such thing as 70 degrees in a room, by the way. No such thing. Because if it's 70 degrees here, it's probably not 70 degrees over there, nor is it over there, nor is it over there. So then in the old days, people would, well, just put a lot of sensors in there. And then one of the sensors is going to pick it up, and then we'll compare all the sensors and we'll average them all out. But you still have the air conditioning coming on and the heater coming on, and then the air conditioning coming on and the heater coming on. Just go to a really old hotel with an old heating system. You go, oh, look, the heater's on. Actually, just come die. Just come die to you. I said I was going to be politically correct today. I'm going to be nice. I'm going to be good today. But then it gets too cold, and then they turn it on. It's because they don't have, I don't think we have we don't have a fuzzy logic auto detector in here. Instead, it gets cold, it gets warm, someone turns it on. It gets hot, someone turns it off, or whatever. Long story short, it's a manual on and off technique. It's either on or it's off. It's never had in the middle. Well, in the old days, the reason why we came up with fuzzy logic wasn't to solve that problem, but it was just keep the hardware from wearing out. Which is the same thing we came up with car pedal, saves gas. So if we give it a lot of gas, and the old systems used to flood actually, if you put too much on the gas, it never regulated. So now we have fuzzy logic regulation on the gas, which means we're going to be conservative. Only put it out there if we need it. We don't need it, don't put it out there. We're going to waste it. It's just going to drip to the bottom and come out just going to burn out the exhaust or whatever. It's not going to really do anything for us. We're not going to get the same efficiency out of it. So in hardware, we turn it on, we turn it off, we turn it on, we turn it off, we turn it on. Long story short, it's going to wear out fast. So we turn it on, we wait. So if we say we want it to be 70, it's really 65 to 75. At 75, we turn the air on. At 65, we turn the heater on, or whatever it is, to bring it back up. And so it's a range of values.
Probability.
I'm sorry?
Probability.
Probability. Yeah, actually, fuzzy logic uses statistics and probabilities to design solutions for when to turn something on and when to turn something off. Yeah. So if you'd there's some cars transmissions that adjust this way too, where it uses fuzzy logic to come up with its timing, and it adjusts itself. It learns the pattern. So if you constantly slam on the brakes or you constantly slam on the gas, the transmission actually shifts differently after a while. I think a lot of the Mercedes used to do that, actually, or BMWs, I can't remember. It was a higher end vehicle. But long story short, when you stick on the gas pedal, it'll give you gas to accelerate to a certain point. It's not going to turn it on or turn it off. It's a range of values that it's going to give you. And you never exactly know how much gas you're really giving it. Just the same way as you don't know how many turns and what percentage of the time you're actually turning the wheel and how many clicks that is. There's no number that does it. There's a range of numbers. So neural networks are based on a totally different concept. An artificial neural network actually makes connections. Both the neural networks and fuzzy logic are related because they both use probability and statistics and other other science theory to formulate conclusions about the data. So in an artificial intelligence system that is capable of finding and differentiating patterns, well, that's what we do as humans. So neural networks work with neurons that connect. So what does that mean? If it's cold in here, we're going to put a jacket on. Our decision to put the jacket on was due to our sensors. So we made the connection between cold and warmth. If it's hot in here, we're going to take our jacket off. So we're making a neural connection. It is a neural connection, actually, between feeling of being warm and wearing a jacket. We're going to take the jacket off. So we apply that to a network of items, and then we get what's called a dominoes effect. Everyone's heard of that, where one thing leads to another, which leads to another, which is actually kind of funny. It's like when you read the news. In fact, try this out. It might actually work, but I'm not guaranteeing your results. Just buy against everybody else. If everybody's selling a site, everyone's talking about something bad, buy it up. Because most likely what will end up happening is people hear that and their natural instinct is to go with it. No, I'm not going to do that. I'm not going to do that. I'm not going to do that. And it's really this percentage of people that don't do that end up essentially working away from the natural stream. So neural networks that work with connections can make graphs of simulations to model business problems. As an example, every year around, September, people start spending more money. Why? Because it's the time of year. They don't know why they're spending money, but they're spending money. Because they're not even buying gifts yet. Gifts don't happen until after Halloween or around Halloween. But usually in another 2 or 3 more weeks, by September 1st, people just naturally start spending more money. because of their following that pattern. So it's pattern behavior that the network can put together. So if you know that, and if you're Apple, you're going to introduce all your new product line in September. Because that's when people start spending money. You know, well, don't wait till August. I mean, don't do it in August. Well, late August works. So neural networks can learn and adjust to new circumstances on their own. So if you have the data and you're able to put it together to test out a theory, and you have the analysis down, and something as easy as when people spend money, it's actually kind of interesting. And most people pay, actually, I don't know where I was hearing this, but most people start paying their loans back in April. April and May, people spend money on loan repayment. They actually start fixing their credit, and they start, because it's closer to the summertime and they want money to spend. So they're feeling guilty from the January, February, March. It takes them until April or May before they start repaying their credit cards. So if you're a credit card company, you're going to offer discounts. You know, here, we'll take a percentage of what you owe. Just give it to us now, because you're not going to be doing this next month. So, well, then, if you're selling chips and you know that certain products sell at certain times a year, then you're going to be working with your chips, or you're selling fruit, or whatever it is that you're selling as a company. You're going to strategically plan with the patterns. So take part in massive parallel processing as well, because you have to look at tons of things. So a neural network is looking at more than one factor. You're looking at several different factors. You're programming it into an algorithm, and then you're coming up with a decision that's made upon that. They function without complete information as well. So you don't know which loans people are paying back, or what people are spending money on, or where people are traveling. So, but you can make assumptions on that, and they cope with huge volumes of information, and then they analyze nonlinear relationships. Actually, it's nice to be able to cross the relationships, so that if you cross the relationships, then you can come up with some pretty interesting patterns. So neural networks, just dealing with patterns. One's connected to another that's connected to another. We also have learning networks as well, learning neural networks that actually learn from their mistakes. So you put the data in, you said, well, are you going to do attendance? No, okay. I didn't know, I saw like personnel standing there, so. Are you just waiting for the next politically incorrect statement to come out of my mouth? I'm being monitored. That's my neural network putting the pieces together. Now I'm seeing staff and management standing at the door. All right, now I'm good this week. Fuzzy logic. All right, what do we got here? We have him waiting for the attendance person. All right, let me get back on track here. In the fuzzy logic solution, as I mentioned before, we're looking, here's the attendance. All right, let me break for attendance. Okay, back to fuzzy logic. We are back from attendance taking. All right, so according to the textbook definition, it's a mathematical method for handling imprecise and subjective information. It's imprecise information in terms of what's the definition of hot, cold, or warm, or not warm. So used to make ambiguous information such as short, usable by a computer system. Short, long, well, what is short? We'll give it a number. Give it a range of numbers. So in terms of the application, it's used for Google search engine, washing machines, anti-lock brakes. Actually, anti-lock brakes are a good application of fuzzy logic as well. If someone is pressing on the brake, then depending upon the speed in which they press on the brake, then the fuzzy logic system would tell it, engage anti-lock brake, don't engage, depending upon what's going on with that. But it's not hitting one precise number, it's hitting the motion or the pattern of the speed that's occurring. So we also have genetic algorithms, and genetic algorithms compare, I know, I'll have to just look at people now and talk louder. Genetic algorithms compare different sets of data across each other. So the systems that mimic the evolutionary and survival of the fittest process to generate increasing better results for different solutions to problems. So what do you do with that? Well, you compare, and in fact, there's a nice little, I think it's, I can't remember which one of the credit card agencies, the credit reporting agencies, I believe there's 3 of them. One of them uses a genetic algorithm actually as part of its base algorithm, which is why we have 3 different systems. They're all using 3 different types of technologies. And one of them does use a genetic algorithmic approach. It looks at patterns in history of associations, patterns in histories of, you were at this job, you were making this amount of money, you had this amount of debt. With that pattern of you made less here, you made more there, and the associations between how frequently you get paid versus how frequently you spend the money, the rate of the spending of the money versus the rate of the income, your expenses and your debits. Essentially, everything that a regular or old credit and debit system would look at, but it looks at the patterns of the associations. So, believe it or not, it is a genetic solution by definition. Because genetics in general looks at gene patterns and puts things together to predict different combinations that lead to different results for different diseases and different patterns of natural selection and things of that nature. So evolutionary principles of genetic algorithms in terms of the selection or the survival of the fittest, giving the performance of better outcomes. There's a lot of science that goes into this for management decision making. As an example, actually for sports, there's a lot of science that goes into this. If I were putting together, for example, a soccer team, knowing nothing about soccer actually, but looking at the history in terms of, well, what makes a good soccer player, naturally selecting out maybe fastest runners or endurance or something, looking at the scale in which, what do I think would make a good soccer player? And then testing out the samples to see if the features of these particular people that I think are going to be good, if you add this characteristic up with that characteristic up with the other one, the combination of all those features, do they turn out to be good soccer players? Stuff like that, which actually employers do it all the time. You take, well, we need a good customer service person, so we need someone with a business background, or we need this, we need that. You find the different pieces and you put it together, given the management science that you're working with, to genetically kind of come up with pattern of, well, what combination of skills do we want to make this person a better customer support person? And then you provide training in the areas in which the person is weak in. So in terms of the selection, you're looking at the what makes good outcomes. The crossover combines portions of good outcomes to create better outcomes. You cross it with something else, which is what they used to say about, actually used to say this about engineering managers all the time. It's good to have both degrees because then you have the cross. So you have an undergrad in computer science and you have a master's in business administration, which is a really good combo actually. Or you have a bachelor's in business administration and you have a master's in computer science. Excellent crossover. In fact, I'd take the crossover over someone who had a bachelor's in computer science and a master's in computer science. Or a bachelor's in business and a master's in business. Not doing any good. But if I were to take the business end, I'd rather have the business at the master's level than have it at the undergrad level. So some of you who are master's people who are engineering with engineering background, maybe that's why you went to engineering management, because then you have a slight management twist to it instead of having an engineering degree with an engineering degree. Not going to give you much, because most HR companies are looking for both. They want the management skill, the business background, and they want the technology background. They want both kind of sets. So that's what it means by crossover. If you take it from a genetic point of view, that's a soccer player that can also bounce a ball, or that can also have another skill that might also be good. And then there's mutation. Randomly trying different combinations and evaluating the success of each. Well, that's when you mutate your decision, your career decision. So you got a bachelor's in computer science and you have a master's in I don't know, let's call it an MBA. And then you decide you're going to be a pharmaceutical tech, or you study pharmacology or something like that, or whatever that's called. So I'm not saying it right. And then you discover, oh, I have a knack at that. Actually, what I think is really interesting are the the computer science students, the masters in computer science or the bachelors in computer science. You guys are musicians. And actually you have anybody who likes math has natural musical capabilities that come out of that. And you think, well, where'd that come from? Well, genetics actually. I'm not lying actually, or I'm not making this up either. Genetics tell you this. From all of the mutations that occur throughout time, they have a higher likelihood. The mathematics, computer science people perform much better in the arts. You think, well, that's really weird, but why would they have a better sense of music? Because math and music have a lot of similarities in terms of the skill set. So your upbringing in your training in computer science or in math has actually trained you to be a better musician. But people don't know that till they do the crossover, and then it crosses over into a different field. Well, actually, computer science people make extremely bad artists, though. They make good musicians, but they're really bad in art, like in visual arts. But they can play music. So, but you can't draw or paint. Normally, you can't draw or paint. And then business students make really, this is just what the theory says. The business students make really bad musicians. But they can do clip art, they can do artwork for music albums, and they can do a lot more of the theater arts and stuff like that, which is kind of interesting as well. So anyway, it's crossover fields. So there's a couple books, actually. I think one of them's called something about a parachute or something. I don't know. They do the same thing with childhood skills and likes and interests, and then multiple personality inventory and a couple of these other things they give you. And these are like college career center tests that you take as a freshman coming into college usually. Or sometimes people take them at a master's level, actually, where you answer a bunch of questions and it puts together an answer for you in terms of what career you should go into. It says, oh, you should study this or you should study that based upon your interests and your likes. And it's using a sort of a genetic comparison, actually. So it takes all the information you've come in with, all of the questions that you've answered, and compares them to other people's questions and answers in an entire database. It makes the connection and comes out and says, oh, you should be a police officer, or you should be an attorney, or you should be a this, or you should be a that, depending upon your likes. So genetic algorithms can take thousands or even millions of possible solutions and combinations and recombine them until it finds the optimal solution, which is what these career guidance kind of things actually kind of do. And then works in environments where no model of how to find the right solution exists, which is actually kind of interesting in terms of problem solutions. So they don't work, and there's no sense for them to be working in an environment that is structured. So it's very much an unstructured environment. And then we have intelligent agents. Everything in the, well, past the year of the, well, I don't know what year the internet actually became mainstream, but I guess the early 90s or late 80s. Since the invention of the internet, we've had intelligent agents all over the place. In fact, the entire internet is agent-based. So in terms of an intelligent agent, is software that assists you or acts on your behalf and performs repetitive computer-related tasks. Well, that's what Google search engine and Yahoo search engine and all those other search engines out there do. So that is actually considered an information agent. You type in video camera and it comes back and tells you, here's a video camera and here's a video camera. So it's an information agent, brings back information for you. We also have monitoring and surveillance and predictive agents. They are port sniffers and port monitors, and actually a lot of spyware work in this capacity. There is some good to the some spyware software out there because it shows us some of the capabilities in terms of what we can do from a monitoring and a surveillance perspective. So it's really, I mean, that's where the word came from, spyware. It's really they're little agents out there collecting information and monitoring situations and reporting back to the mothership what's going on out there. So, which was the intended nature to begin with. Well, what are people searching on? What are people doing? So, actually, I hate to tell you, Mr. Google, but some people, I was just listening to something the other day about some people claiming that some of the new technology that Google's come out with is borderlining on spyware at this point, because it's doing a lot more tracking than it used to do. So
Yeah, we had that with emails also when we began.
yeah, there's a resurgence of sentiment out there that Google's turned into a spyware company. So, yeah, I was actually at not a conference, it was some sort of a meeting, I can't remember where it was. It was over in the East Bay, actually, and it came up and I'm like, yeah, now that I think about it, and it's that G+ stuff that's linked. So they've turned into a spyware company. So I don't know, what are you going to do, stop using them? I mean, what are your choices? Yeah, I'm not going to stop.
Germany, so started in Germany.
They started what?
I mean, this entire thing started in Germany.
Started in Germany? Yeah.
People spying this.
So you agree then?
It's not spying. Socializing.
Socializing. Well, there's a bottom line between what's socializing and what's spying. It's like stalking and befriending on the internet, you know. At some point I feel stalked. At some point I feel like I'm being spied on. And it's almost to the point now where I've gotten a little paranoid. So on some computers, I don't log in. I will not put my Google information on that computer. Because if I go to YouTube and I start looking at music videos or something, I don't want people thinking that that's my music taste or something, you know. Just because someone told me about an artist and I have no idea about the artist and I want to go check it out, I'm afraid to use my computer for that. Because I think someone's going to be spying on me. Because believe it or not, I've actually seen this on people's accounts. You know, you go, oh, what is that video up there? And they go, oh, I looked at it. Oh, so now it's in your favorites? Now it's following you, you know. Which I don't necessarily want the world knowing what I'm searching on. So, not that I'm searching on, you know, anything bad. It's just I search a lot on music actually, but you know, that's because I'm a computer science person. I have music capabilities. So I have an interest in music anyway. So long story short, data mining agents or other agents, well, that's really, Google's more of a data mining / surveillance kind of system. User and personal agents, SGs, if you remember that one, that was a intelligent personal agent. The paperclip in the Microsoft Office from years ago. Do they still have the paperclip? I think the paperclip's gone. That was an information service agent. The help guy. I think they took the paperclip away. People didn't like the paperclip. So it was entertaining for a while, then I shut the paperclip off. So information agents. Actually, you know, just another thing about Microsoft Office. If you're relying upon Microsoft Office grammar and spell checker to correct your work, probably need to be aware that it's at a 5th grade level. So kind of, you know, when I heard that, I went, what? Like, I'm barely writing at the 5th grade level? No, it's actually kind of different. The agent works at that intelligence level, so it won't make suggestions past the 5th grade. So if you're writing a sentence that's above that level, it's like maybe a college level sentence, it won't recognize it, just leaves it alone. But if it's underneath that, it brings it up to a 5th grade level. So I had no idea that was the case, but now I do. So we all write at a 5th grader level. Well, you think about it, though. I'm not going to go into average intelligence in the U.S., but okay. Information agents. Information agents that search for information of some sort, buyer agent, shopping bot. Shopping bots are pretty popular. Intelligent agents on the web. Actually, a lot of products are agent-based these days. Just think of eBay as an example, agent-based. So, in fact, now I don't mind it when eBay does that. eBay keeps track of what you've searched on in the past, and then it'll show you things that have come up that you've searched on in the past. So, but I don't see it the same way because I can easily clear that out and it updates versus some of the other things. So monitoring and surveillance agents, well, they're predictive. So they constantly observe and report on the entity of interest and the network and manufacturing equipment, for example. So in a good sense, you can use a monitoring and surveillance agent in an assembly production manufacturing line to predict. In fact, you see this in your cars all the time. It tells you when your car tells you that it needs to change the oil. You know, say kind of time for service. Well, it's a monitoring surveillance agent that's built into the computer of the car that tells it that you've driven so many miles, or it's been hot, or it's been cold, or the driving conditions have been such and such, so that now we need to have the oil changed or something. Whether it really needs it or not, who knows? It's the surveillance and the monitoring that's doing it. Data mining agents operate on warehouses, discovering information. A data mining agent is different because it comes back and tells you things you didn't ask for. In a regular search for an information agent or surveillance agent, you generally have to ask for something, and then it comes back and tells you. In a data mining, it just tells you. It says, oh, this is going to break down. Oh, that's going to break down. Oh, okay. Or you need to sell that stock. Why? Because the agent told me to, or whatever. User agents or personal agents. For example, prioritizing email. We have it. Actually, the agent concept's built into your email programs if you have any sort of priority-based or any tagging system on your emails, depending upon what programmer you're using. Maybe a gaming partner, maybe in terms of an internet game of some sort, assembly, customizing view reports, filling out forms for you. Actually, the user agent fills out, in terms of the concept, when you start writing in information on a report. It does the autocomplete for you, discussing topics with you, stuff like that. Most systems are multi-agent systems that are following some sort of an agent-based modeling situation. So if someone comes up with a business model, they come up with the agent model that works with it, they implement the agent model to enforce the business rules and to really put the business model to use. So using biometrics or biometricity and learning the ecosystem, adapting to characteristics of human and organizational situations, learning how people work, people-based systems, how they behave, predicting things, improving the human experience and efficiency and effectiveness. So an agent-based modeling technique is a way of simulating how a human would think, but doing it in a computer program. Most of our applications work this way these days. Because if you can make the application think like the human, then the human doesn't have to learn the application. The human just uses the application because it's more compatible. So a lot of people in the UI industry are sort of looking at this like, well, let's make it natural. So using things like voice commands, using handwriting recognition, touch control, gestures that mimic human gestures and things, make it more adaptable. So what we're looking at is an agent-based modeling system that makes the application interface better with a human, and then looking at multiple human agents, following a set of simple rules to adapt to changing conditions and things of that nature. Now that would be interesting to see. In fact, a lot of the stuff with the 3D glasses and 3D modeling and things that are going on these days, to mix right in with the human thinking would make it easier for game playing or for productivity, actually. So, multiple agent systems, grouping different agents together, giving them ability to work independently or interacting with each other. So in terms of business applications, to put all this stuff together and say, well, okay, that's a lot of theory, but who uses this stuff? Southwest Airline uses it for cargo routing, and I'm sure I brought this up a couple of times, especially with, what was it? Well, now I can't think of the airline company right now that sells their cargo. P&G Supply Chain Network, Supply Network Optimization for supply chain management. They were one of the first companies that came out with automated supply chain management. Every airlines actually is going to be doing intelligent-based systems for scheduling and for routing. You can't sit down. It's no longer cost-effective, and you can't do it with a spreadsheet. You can't do it with a human base. You have to have a computer do it, actually. Because if you don't actually get an opportunity to have it finished before the flight needs to leave. It takes too long, and it doesn't shift and adjust in real time. So if you put all the flight schedules of all the flights of all the airlines in a computer system, schedule the routes, schedule the rates per the seats on the plane, the cargo that you're selling underneath the plane, and then we have a storm in Denver. Within seconds, the system can adjust. It would take, a human or a couple, it's probably a group of 5 humans or 6 humans, days to calculate that out, to figure out, well, because it's too complex, to figure out, well, how are we going to adjust everything, move everything around, which flights are we going to cancel to make this work faster? So instead, they just make rash decisions, like, okay, just cancel everything. Okay. So now you can make it work. Distributing anti-AIDS drugs in Africa. Ford. Balance. Actually, that's interesting. They used a geographical information system because there's no technology out there. There's just people out there, rural areas in the outskirts. Actually, your veterinarians and the animal rights people, not the rights people, excuse me, what am I thinking of? And not anthropologists, but the people who study animals. The people that go out in the jungle and they study reptiles and animals and stuff, they use a lot of business intelligence, artificial intelligence, and it's usually they'll tag, what do they call those people that tag animals? They put something on the ear, staple something to the ear, they watch them for several years, they come back and say, oh look, this one's still around, and then they get data from the tag or something, or they get information that came from that person. They're using technology and artificial intelligence to kind of figure out what happens after 5 years of eating just rice or something, or what happens with the patterns and stuff. So, Ford to balance production costs with consumer demand. Edison, of course, never heard of that company. Deploy service and supply vessels. So, then we have swarm intelligence, collective intelligence, which is now we have crowdsourcing, which is another kind of a buzzword that we have these days. And it's nothing outside of, it's nothing new, it's swarm intelligence. So it's the ant theory, the collective behavior of groups of similar agents that are capable of devising out solutions and solving problems, eventually leading to coherent global patterns. So now the ant theory, though, is pretty interesting, though. It's like humans act like ants in a lot of ways. And they've been saying that for years. So, well, it's because they travel in packs. And they're supposed to be working together, companies. So it might be interesting to be standing above the earth, like, 3,000 or 4,000 feet up in the sky and looking down on the humans. And going, look, they look like ants. No, and going, well, what do? Look, they go to these restaurants. Oh, look, they drive around in these little cars because they can't walk anymore. Oh, look, they do this, they do that. This studying human behavior must really be interesting to somebody. So. Characteristics of swarm intelligent agents. Intelligence is flexible, adapts to change well, robust, takes the completed even if some individuals are removed, which is actually kind of interesting. That's how they do the pattern recognition for people in malls. Some people will drop off, some people will go home, some people will come in, new people. But they can still look at the common pattern that occurs. They do this with freeway traffic too. And they can see the majority pattern and how the pattern moves around. So there's actually theories in terms of placements of things for retail people. Decentralization, each individual has a simple job to do in terms of the big picture. So that was all I'm going to give you on an introduction to artificial intelligence and how that works with business intelligence for better decision making. The next lecture, because I have a little bit of time left here, I'm just going to start in with this next one, and then we'll finish this next week, and then next week we'll also do our review. Because once I come up with the questions, what I'm going to do is kind of give you some hints about what to look into. Now, you can't do it for the case study, though. Case study is too easy. I mean, not too easy. It's too hard to study for. But if I were to ask you, as an example, describe how business intelligence can be used to make a company more profitable. Then you'd have to think, well, let's see, from today's lecture, I could apply artificial intelligence techniques to, I don't know, see what the buying patterns are, the money spending patterns are, or do something, some creative solution. So what am I really testing you on then? It's not really memorization. It's just the ability to kind of see how you could apply certain things from different disciplines together. And basically, I guess it's a source of creativity, perhaps. I don't know how I would study for a test like that. Now I'm thinking about it. So I'm going to have to come up with something to tell you in terms of hints next week. So I'll just have to make some stuff up, I guess. Actually, I told another class, it was a programming class, a Java programming class. I said, just print it all out and stare at it. It actually does work for some people. Print something out and stare at it. If you're trying to memorize something, you print it out, you put it on the wall, or you put it next to you, look at it, and go, oh, and you try to read it. Memory image, yeah. Remember what it looked like. It was only 2 lines, and then there was another line, and there was another line. What were those lines? I don't know. All right, so this is lecture number 10 of the MIT. The last one was of the information technology, the MIT series as well. This one is on enterprise infrastructure and business continuity planning. One of the things you need to do as an engineering manager is when you lose your power at a bank, well, not the engineering manager, but the bank manager needs to figure out, well, how are we going to use it when the computer system goes down? And then if the computer system does go down, how are you going to bring the computer system back up? So for fault tolerance, for continuity of the business, how are you going to continue operating if your manufacturing plant goes on strike? Which, if Bart could probably take a lesson from this, how are you going to continue running if your people go on strike? Actually, they're talking about going on strike again. I don't know if they have done this yet, but there's going to be another strike.
They have kept the decision pending for the next 7 days.
Oh, fantastic.
Because the government came into action and stuff.
Oh, finally. Yeah, I think it's against the law for them to go on strike because they're a public utility. So, I don't know. Anyway, that's what this lecture is about. Describing how service-oriented architecture can be used as a philosophical approach to help organizations of the future. Also looking at business continuity, describing business continuity planning and its phases, defining and describing various hardware and software infrastructure considerations to support this, and also looking at metrics for assessing the success of these plans. So this is an interesting one about the IRS actually. Nor rain, nor snow, nor dark of night. The IRS will continue. Now that's one company most people would love to have out of business. Yeah, honestly. So in 2006 there was a flood that hit an IRS office in Washington actually. And a 4-foot wall of water just went and wiped everything out. Took out the computer system, took out the paper, took out everything. Made it so that the building was useless for the 2,400 employees. They had no place to go. Yet the IRS recovered. You know, they should have just shut the doors and called it quits, and anybody who had owed them any money now got forgiven, you know, or anything, you know. Nobody had to pay taxes anymore. That would be nice. But unfortunately, that didn't happen. Because fortunately for the IRS, they had a business continuity plan. And they were able to pick up and carry on business the very next day, including data recovery centers and data centers that were geographically separate from the building. So they didn't have all the information on site. So no data was damaged. Bummer. And all employees had plans to, in place of work, or they were put in other places to work. They had other offices that they could locate them at. So. And the downtime was minimal. Well, it's unfortunate for the citizens, but the IRS has continuity plans, believe it or not. Sort of personal continuity plan. Well, what kind of do you have for your life? And think about it, and you go, well, I don't know. I certainly have a lot of plans when it comes to my car, because I have multiple cars, but in terms of my house, yes, you may live according to my house. I only really have one place to live. Let's see, are there brick and mortar businesses or click and mortar businesses? Are they more susceptible to disaster or other interruptions? Well, actually, that's an interesting concept. If you're an e-commerce company and you're a click and mortar, not a brick and mortar, then are you more likely to go out of business due to a problem? Actually, the answer is yes, but which is kind of interesting because you'd think you wouldn't have a problem. All you have to do is lose your technology and you got a problem. All you have to do is have a really bad server and you got a problem right there. Or better yet, get a virus on your server. Or better yet, have anything go wrong technology-wise and you've lost your customer base. So when was the last time you were dealing with a company and someone said, I'm sorry, our computer systems are down. Oh, I too. And I can't check your account right now. I don't know. Computer systems don't go down. I'm actually still lecturing, by the way. Thank you. It's okay. I've adapted to the changing environment here at ITU. People just, they talk, they have lunch, they play games, they shop for stuff, buy airline tickets, I don't know. But okay, I just don't like talking over people. Thank you. Alright, so, a long time ago, around in lecture 6-ish, I talked about service-oriented architectures. So this is the pickup from the previous lecture in terms of the service-oriented architecture and the perspective of the development of continuity for an organization. So as an example, if you've got everything, let me refresh your memory on what service-oriented architecture, actually I should just ask you to write on this for the final. Describe service-oriented architecture. I wonder how many people would actually be able. I've talked about it 3 times already, actually, in this class. This is the 3rd. So let's see. Now that it's quiet, the focus is on development, use and the reuse of small self-contained blocks of code called services to meet all the application software needs. So you can use service-oriented architecture for business continuity planning because, as an example, if it's broken out into small serviceable pieces, one of them goes down, the rest of them are still up, the rest of them are still running. Plus, they're also managed by multiple people. They're not all managed by you. And some of them are services that are software as a service. Some of them are cloud-based resources. And some of them are on-site, not on-site, and they can be used in different combinations, and the company can grow and expand using these just quite easily. So software code is not developed solely for a simple single application, it's developed for a platform. So services are built that can be used and reused across all applications. Nice way of making some continuity that is replaceable, that's extendable, that's flexible. So you can extend the service-oriented architecture into the entire organization, and this is one approach that you can take. So it would be to learn in Agile using resources in the best way, proactive addressing changes in the market, quick to respond and adapt to advances in technology. You're not stuck, actually. Transformation of processes, structure of HR initiatives, matching changing and dynamic workforces, and being able to adapt essentially to a highly changing and very flexible environment, so that you get in an engineering background or an engineering company. So the focus is specifically on IT for customers and user software development, information needs, and hardware requirements. So the service-oriented architecture is definitely an area that a lot of companies are using because it provides for not only business continuity, but it gives the business a better, solid, more foundational base of IT resources. And it's affordable because you're renting services. You're not necessarily building an infrastructure on your own. So in terms of customers, you got multi-channel service delivery. You got consistently high quality interactions regardless of the venue. You got customizable products and services and capabilities. So you can provide more customer service quicker, faster. Customers should be able to plug and play into their organizations and have the same pleasurable experience regardless of the channel, regardless of the route that you're taking through your marketing. For end users, well, you could also have a fully integrated ERP system along with this so that your entire organization is connected. So you have interoperability among vendors. So the vendors themselves could cooperate or coordinate, I should say is the word I was looking for, their solutions and their products and their services too. And at the same time, you have the interoperability of modules by the same vendor that can be mixed in with this as well. So, and then mobile computing, access to information and software regardless of the location. So end users should have access to whatever they need information-wise and software, regardless of where they are. So, in terms of software developers, well, the framework gives you a nice foundation to work upon in terms of making your integrated applications work well together. So we have a RAD, extreme programming. Remember all those different programming techniques we talked about with software engineering, software development, Agile, and all these development methodologies that can be used with this. And exciting new deployments like Web 2.0, actually Web 3.0 at this point as well. So focusing on reusable components essentially. And in terms of the information needs, we have the end users with access to all different types of information and services and data warehouses and standard information formats, integrity control. So hardware, large storage capacity, much larger than a regular old database would give you, or an in-house system. Integration with different technologies and platforms. Safe. Hardware is both integrated and transparent, which is actually interesting. In fact, this is probably the biggest selling point, is the hardware requirements, the hardware information. So the biggest fear a lot of companies would be is saying, you know, can we support the network speed? Can we support the hardware? Are our systems big enough? Can we grow? Can we shrink adequately? Well, if the software is the architecture that's associated with this and install service base, you just add more service. You just increase your service line. It's like you don't have to worry about installing anything or using anything. It's part of the architecture. So you already have the capability whether you need it or not, and when you need it, we'll give it to you. And then when you don't need it, you don't have to pay for it. You don't have to use it, which is why a lot of people actually do the cloud services concept. Because if the architecture itself is supporting the growth, then why do you have to bother with this? You know, as a company, you want to put your money where you need it, not necessarily spend. In the old days, people used to go out and spend a lot of money on the infrastructure, a lot of money on the hardware, building this themselves, integrating everything. Instead of having small little applications, they had this huge, big, massive orb, you know, this whole big business system, the old IBM business systems. You can't touch one for under $200,000 or $300,000. What startup company is going to buy one of these? Nobody's going to buy one of these, so you can't afford it. And in back when you could afford it, you still couldn't afford it. People just bought it because they needed it. They felt they needed it. So now the whole infrastructure is so different that it supports a lot of the different variations that go on with a lot of entrepreneurial and startup companies. So the infrastructure is the structure beneath the structure. That's the infrastructure by definition. And so it's really the IT infrastructure is the implementation of the organizational architecture. So if the software-oriented architecture, then what we're looking at then is an orientation between a structure built on the people, the processes, the ERP system, the hardware, and then also the public utilities, the fire and the police and everything else underneath it in terms of the public infrastructure. Which is actually kind of interesting because people don't think that the business needs any public infrastructure. It has an internal and an external infrastructure, which is kind of interesting. You can see it in companies that go broke real easily because they have a really nice internal, but they have no external infrastructure. Which is kind of like, you know, I don't know, pick a high-end store. Pick, you know, I don't know, what's a high-end retail store these days? I don't know. Nordstrom's, I don't know. Bloomingdale's. Put it in downtown San Jose next to I2. See how popular it is. Not so popular. That's because the external infrastructure is not supporting it. It might have a really nice infrastructure on the inside. It might be a self-contained Bloomingdale's. Saks Fifth Avenue, I guess, is another one, I guess. But it's in the wrong neighborhood. And there's no walk-by traffic unless you take the bums from under the bridge. They're not going to be shopping there. So, which is actually kind of interesting because what ended up happening in San Jose is they took, well, it's Santana Row, which actually I think was actually kind of interesting. The whole concept works with, this is related, this is not a tangent, it relates with this, not with IT, but it works with the public and the private infrastructure. They created their own public infrastructure by creating their own community. It's a city inside of a city. They took and created a high-end San Francisco, not a high-end, but like a San Francisco slash better than San Francisco. It's higher end than San Francisco. It's more upclass than San Francisco is as an entire city. They built their public infrastructure and then they built it as a private infrastructure. So it's you go there, you park your car, and you walk down Santana Row. If you guys have ever done this, it's interesting. You're walking into a different city. It's not San Jose. It's not Los Gatos. It's not Palo Alto. It's not a downtown anything. It's Santana Row. It's a separate infrastructure in itself. They built the public so they could support the private. So those little stores down there are expensive. You can't get a building. You can't rent a store in there. It doesn't go by San Jose pricing. Well, you can if you have a lot of money. The people that rent the buildings that are down there are spending more than they would if it were in San Jose, but it is in San Jose. But that's what I mean by a public and a private infrastructure. Well, it's interesting, but every company has a public and a private. And then they also have an IT infrastructure that goes along with it, which is kind of interesting. You look at the building and you go, well, it's just a building, but no, it's working as community. So if you're a certain type of organization, you're going to locate in a certain area of the world. You're going to have a different infrastructure as your public interface and also as your private. And then you're going to build the information technology and systems to work with that, which is kind of interesting. So anyway, ERP revisited. I think I'll stop after the ERP. But looking at the concept, enterprise resource planning can build the infrastructure for you, which is the reason why we're revisiting it here. So from lecture 2, a long time ago, we talked about, and hopefully you remember this, enterprise resource planning. So What I'm going to do for those questions, by the way, is I'm just going to, for the option that's not the case study, I'll just have like 4 or 5 questions and you'll pick one of them. I'm thinking about doing one on ERP actually, but I'll give you the subject areas. So next week I'll say, 1 question's on ERP and how it can be used to build a private infrastructure. Well, 1 question's on that, so what you'll have to do in the meantime is figure out what in the world is she talking about. What in the world's ERP? What does that mean? And then figure out what if I were going to answer a question on that topic area, what am I going to say? And you get points for answering stuff that makes sense, right? So hopefully. So, and in terms of ERP, to refresh your memory on that concept, and how you're going to refresh your memory on all these concepts is next week I'll give you a list of lectures. I'll say, look at this lecture, this lecture, this lecture, this lecture, because it's all PowerPoint, so you don't have a book. So I'll outline the lectures that you should look at so you know which ones to review and which concepts to review so you can prepare yourself. So it's a collection of integrated software and business solutions, management, accounting, human resource, everything. Put it all together, put it into one system, call it an ERP, enterprise resource planning, inventory, customer relationship management. It's big business. It is a huge system made for a big system. So federal government will spend $7.7 billion on ERP in 2009. Well, they did already. 60% of the Fortune 1000 companies have ERP systems. So it dominates the ERP. We only have SAP. Actually, if you're interested, you can take SAP classes at ITU, and you can get SAP certified. And if you're looking to get into something easy from a non-technical perspective and you're a business person, take SAP. There's a ton of jobs in SAP, actually, if you're looking for a job out in industry. I wouldn't do PeopleSoft. PeopleSoft, not so good. SAP, a little bit better, more popular these days. Although PeopleSoft and Oracle is on here, one bought the other. So Microsoft, don't waste your time. SAP is where you want to waste your time. Where you want to take classes if you have an interest in it. And then you have to take ERP classes because then you'll have to know how to work with the infrastructure because it's all about building ERP systems. And SAP is sort of like the glue that keeps everything together. So it's the communication protocols. So about 50 or so established emerging ERP vendors. So here's a couple of i2's still around too. Some of these guys are still around. Some of them are more popular than others. Everyone's making an ERP system. In terms of the evolution, we have MRP. So it focuses on the production, planning, calculating, time requirements, procurement, manufacturing. So manufacturing systems. MRP2 closed the business loop in terms of the financial accounting systems, added those features for decision support tools for managers as well. So late 80s, early 90s, the focus on critical time to market solutions. Shorter lead times, customers want it now, they don't want to wait. Today, the focus is on completing everything in the cycle. So customer relationship management, business intelligence, host of different applications as well. So how does that work with software architecture? So software as an architecture, well, for ERP systems to integrate everything, it builds the infrastructure for the most part. Everything must be plug-and-play components. So we have software that are services in this architecture. The services are performed in the ERP system, so it's all in together. So all modules of the ERP vendor must be interoperable. If it's not interoperable, there's no need for the system. It's not going to work correctly. So we have to have all the pieces work together. Multiple vendors must be interoperable, which means people must communicate. So if you use something like, SAP is the middleware ground for it, then everything works. It's all a module that works with everything else. So, and the infrastructure beneath must be hidden from the users and the consumers, so we don't have to worry about the technology. We just use the system, and the system is made up in terms of the concept of a bunch of components or services, and we're using it together like a system, even though it's made by different vendors, and it might even be located at different areas as well. All right, so I have to go to a meeting in 8 minutes, so I need to stop. But I wanted to make sure I at least started this lecture. So next week, we will finish this lecture, and then I will give you your final exam review, and that will be our last lecture. Unless we have any questions, comments, or concerns. If we do, you can always send me an email message as well. Otherwise, I will see you next week.